Today's lecture is on data collection and scraping. All right, so let's get started. So today's class is going to be in 4 major sections. We're going to briefly talk about what data collection is and why it is important. Then we'll talk about the sources of data. Then from there, we'd move to data formats and handling before we then head with regular expressions and parsing. So between each session of this class, we're going to have a mini quiz, after which we then go for short 3 to 5 minute breaks, just so that we can recalibrate, refresh, drink water, take a coffee, or just move around a bit. So we're going to be starting with data collection and just a quick introduction. So data collection is a broad part of the data science lifecycle. So those that were in last class, you got an introduction to what data science is as the intersection between multi-disciplines to take data, analyze it, derive insights, and put it towards some meaningful use, some business decision or some strategy moves, or even in your personal life, if you're that kind of person who likes to be as statistically detailed in carrying out actions. But there is a process to it. There's a workflow to successfully carrying out a data science project or to have a data science solution end to end. So one of the first things is always to understand the problem. So that's, you need to make it clear, you define the problem. So once you define the problem, it makes you understand the kind of data that you're going to need to solve the problem. And the next step then becomes collecting that data, which is what we're discussing here today. So you can see how it is very important because data science in itself depends on using data. Now, if you don't collect this data, if you don't collect it correctly, if you don't collect the right data, then your solution is bound to fail. Not that you won't get a result, but you might get the wrong results, not what you're looking for. So that is why this process is very, very important. So once you're done with that, you can then clean the data, explore, build a model, rinse and repeat. Okay. So the next thing we're looking at now is sources of data. So data is generally grouped into two sources, but data is generally sourced from two major categories. We have what we call primary and secondary data. So my option 1 here, which is surveys, polls, focus groups, etc. The example of primary data. So what is primary data? Primary data is data that you get directly from the source, directly from the source. So when you carry out a survey, you're getting first-hand information from the participants of that survey. When you carry out a poll, how many of you like this? What's like the feedback form that you're going to fill? How do you feel about this class? The information that we are going to collect from that poll, from that feedback poll, or from that feedback form is an example of primary data. Focus groups as well. So a focus group is any group that is targeted towards a particular cause. So whatever information you're getting from there is always going to be first-hand. That's what you mean by primary data. So secondary data is data that is already, that is collated from, say, different primary sources and made available to others. It might have been processed to an extent or not, but it is not directly from the source. So every example in 2, 3, 4, and 5 is an example of secondary data. So when we talk about data extracts or data download, that is data that you're handling. So an example is a CSV file. If you go to, say, the World Bank Open Data platform right now, and you are looking for happiness index data, once you download it, that's a data extract, that's a data download. It's a CSV file that you can use for your work. If you take a database and you extract it, you get a data dump. That is the data extract that you can work with. Another source of data is a database query. So you have an existing database and you write some SQL command and you generate a table view. That data is secondary data because you accessed it from somewhere. And now to the more interesting bits, API queries. That is, you're sending a command to a particular interface and asking it to give you some data that you require. That is another source of data. Then the almighty web scraping. I'm sure some of you might have heard of this. It's not this big, scary thing. It's basically saying you're going to the web and scraping off data from it. So think of it like you're eating, you're scraping the plates. That is what web scraping is. You go to the web, you scrape some data off of it. And how are we going to be doing that? We'll be doing that using HTTP requests. I just wanted to point out that in this lecture, we're going to be focusing on API queries and web scraping. In next week's class, we're going to be looking at using database queries. So to start with HTTP requests. So HTTP is it stands for Hypertext Transfer Protocol. It's basically a protocol that is agreed upon by the internet to make requests to resource hosts and to access resources from these different hosts. So whether the resource is a web page that is hosted on a website or a resource like data or an image located somewhere else. That protocol, that's www.google.com, www.aisaturdaylagos.com, that returns the result that you get on the web. That request, that's using that URL is an HTTP request. It's a protocol. It's an agreed upon standard that is used by the internet to get or to access resources. So how does this typically happen? So according to IBM, I feel like this is a succinct explanation of how HTTP requests work. So an HTTP request is made by a client to a named host. So the named host is your google.com, which is located on a server. Now, google.com is hosted on Google servers. You don't necessarily need to know where it is. Now, what is the aim of this request is to access a resource on the server. So when you make a simple www.google.com, what you're trying to access at that point is a search engine. Now, when you get a search engine, you can then make a request. So like you can then search for anything else to point you to the website. That's a simple HTTP request. So I put this here so that you understand first and foremost that it is not some big phantom thing that's HTTP request is big. No, it's what we've been doing every day. You go to facebook.com. It's as interesting as when you're using your phone and you open an app, you open your Twitter, you open your anything, you click on a link, it loads a page, it loads a tweet, loads anything. That's a HTTP request. So how does this work? The client uses a URL. So it's like I said, your twitter.com, your google.com, or in lay terms, a web address. So what's the link to that website? What's the address? That's what you call a URL. It includes information that you need to access the resource. And the parts of the URL usually explains the URL. So a complete HTTP request usually contains at least two of the following. So a request line, typically most people in lay terms, they just use the first request line, but that's the beauty of browsers. So the request line usually is that we interact with most of the time is the web address. So www.google.com, that's your request line. But what you don't know, what your browser encapsulates for you is that it sends some standard headers along with that request to the resource that you're trying to access. So that's these first two, the request line and the header. More on header in following slides. Then if at all you need a body, if you need a payload, so if your request is going to require some parameters to be very sure about what you're looking for, then that's what you call a payload. So a complete HTTP request will contain at least two of the following, which is mostly 1 and 2. So now, what are the standard HTTP methods? You have get, post, put, patch, and delete. So get is the method to use to retrieve data from the resource. Post means to create new data. Put means to update and then replace a resource at that URL, that location. Then patch means to update something by modifying it at a resource. And then delete is to delete the resource. I always tell people that one of the beauties of this field is whenever you have things like methods, processes that you want to do, they come up with action names, like action words. So you can see that these are all verbs: to get, to post, to put, to patch, to delete. So it's kind of self-explanatory. It is something that you can think about. Like if I want to get data from here, then you know that you have to use a get method. If I want to delete something, it's literally a delete method that you're going to use. So having explained HTTP requests, how do we handle it in Python? Thankfully, Python has a built-in library called the requests library. So basically, this library contains a bunch of methods that you use to interact with resources over the web. So you can make requests to a particular location, you can write, you can retrieve data, and then you can peruse the data by investigating further. It also contains some methods that you can use to assess the nitty-gritty of the data. So this is a sample code on how you're going to do it in Python, for instance. So first you import the requests library, and then you get a response from that URL. So it's a simple request.get, like I said in the last slide. You want to get information from google.com. So you get a response. Now, the response you get comes with a certain number of properties because, you asked it to go get something for you, right? Which is what you get, your response. So now, how does this response return? What does it come with? It comes with a bunch of stuff. There's usually what you call a status code. There's what you call the content. And very importantly, you have the headers. So now, the headers and status code are two things that you can look at to get more information about what the response is. So I'll explain that in a bit. So what does the response of status code do? It returns a 3-digit code that shows the status of a request. So if your request was successful, you typically get status OK 200. If a file was not found, those are the common ones. If you have 404, I'm sure people have read this a lot, error 404. And 500 is server error. So now the content of the response is going to be the actual data contained in the response body. And then when you say response.headers, this contains metadata about the response received from the server. It contains properties that would enable useful manipulation of the response on the client. So let's take another example. Okay, let's take another example. So, or just a breakdown. So I want to explain what a URL is. I took a link. I literally just picked this link from one of the tabs I had open on my laptop. So I was searching for the meaning of the word Nexus, right? So I'd already made the Google search and I copied the URL. So how does this work? A URL is typically an address plus a query that could have parameters or not. So we're trying to break down this particular link. The address is google.com/search, right? That's the first step. Yeah, so google.com/search. And what are the parameters in this URL? So you see everything that comes after the question mark, the URL. So you have google.com/search, question mark, Q equals Nexus, OQ equals Nexus, GSLCRP equals this bunch of characters. Source ID is Chrome and IE is UTF-8. All of these together are the parameters in this URL, in this query. Those are the parameters. So now, if you want to get the output from this Google search, what you can do within Python is you make a GET request to the address to where you want to get the data from, and then you pass these parameters as an argument to the GET function. So you say params is equal to params. So params is the name of the parameters that it's expecting. So once you pass these parameters, you get a response. So now I wanted to explain, I mentioned something about the response headers, giving a lot of information about the response that you're getting. So if you decide to display the response headers, that's response headers, you can see this particular variable called content type. It's telling us that the result that we're getting from this request is an HTML content. So it is text and it is in the HTML side. So with this alone, if you're thinking of how to process the data, then you're going to be looking for something that processes text and more specifically processes HTML. You have the date that this data was retrieved. You see that the cache control is private, security policy, you get the content encoding, you know what server the response was gotten from, and so on and so forth. So you can see that it contains a lot of information. And there are multiple other methods in the response class or in the response object that you can always use to access information that you get from the web. So there are different, I could use a print function here, right? But the display function is, it depends on the IDE you're using really, because I'm sure if you use display on say VS Code, it's not going to work. But if you use this in say Databricks or Google Colab, it's going to give you a response. So it will work or not. But it essentially does what a print would do. So the next source of data that we're going to be looking at is API queries. And more specifically, we'll be looking at RESTful APIs. Now, what does REST stand for? REST means representational state transfer, and API stands for application programming interface. So then what is a RESTful API? A RESTful API is a web API that conforms to the REST architectural design. Now, let's take a step back. Representational state transfer simply means, or simply stands for how you want to represent data or how you want to transfer data across the web. The protocol, it's another protocol for data exchange over the web, basically. In what way you want it represented, but very particular about the state. And what is an API? An API is basically an interface. You know what an application is, you know what programming is. An interface is just it could be a program, it could be a platform that interacts with different entities for exchange. So now a web API is an API that exists over the web. So what does that tell you? That there are some APIs that are not over the web, but when we're talking of RESTful APIs, we're looking at APIs that are actually available over the web, such that you could enter an address and actually be able to hit that API. So now we said a RESTful API follows the principle of the REST architecture. Now, what is this principle? What are these principles? The first one is a uniform interface. Sorry. So what this means is across board, anywhere in the world, whatever the application, if you're going to build an API, it needs to have a uniform interface. That way, you'll be able to identify it and you'll be able to interact with it in the same way across board. Then the next one is a client-server relationship. So the idea of the client-server is that for you to have a RESTful API, there has to be a client requesting a resource from a server. And then the server is always going to feed the client with a response. So there has to be that relationship, otherwise you don't have a RESTful API. Then statelessness. So now an API is considered RESTful only if it is stateless. Now, what does state mean? Statelessness involves the fact that when you send a request from your client to the server and the server sends a response, the server does not hold any information about what the client sent to it. So meaning that if two people are requesting information from a server, the server should not use information, should never be able to use information from client A's requests to serve client B. Rather, client A's request is its own request. Sends a request to the server sends a response to client A, and that's the end of the relationship. If client A needs more information, even on the same thing that was asked, it needs to make a fresh request to the server. So that's what statelessness is. The server does not know anything about the client apart from the payload that was sent when the client was making the request. That's what statelessness is. Then cacheable is, so now that I've explained statelessness and I give an instance where if the client needs more information, they need to make another request to the server. Now, cacheability means the client can actually choose to cache the information that was returned from the server. Now, if the API can send cacheable information to the client, then we have a RESTful API. Then it has to be a layered system. What does a layered system mean? What it means is you could have a big application with multiple functions. So again, let's use a popular website that we know about, say Instagram, for instance. So Instagram has your timeline. It has a feed where you see everybody's posts. Then Instagram has DMs, that are direct messages. Now, it wouldn't make sense to be on your timeline, to click on show me my timeline feed, and you start seeing DMs, right? So that's exactly what layered system is. It means there are different layers, and as such, if you're communicating with an API at a certain layer, as part of a certain function, you should be able to interact with anything else on the other side. In fact, you don't know what is on the other side because it is layered as such. That's what a layered system is. And then code on demand, which is optional. It's possible that the server gives access to return some code, some lines of code if the client requires it. But this is an optional requirement. So all these principles actually make what you call a REST API. You would notice that all of these are mainly pointing to a particular thing: the security of the system, the security of the data, the integrity of the data that you're going to get. is actually taken into consideration when you look at all of the principles of this REST architecture, which is one of the ethical concerns when you're dealing with data collection. So it's another beauty of RESTful APIs. So how do we interact with RESTful APIs in Python? We use the standard HTTP methods, get, post, put, and delete. I mean, any of the standard HTTP methods is how you interact with APIs. And this is because the APIs are available on the web, and these are HTTP methods that you use over the web, so standard. But an interesting part is with APIs, you almost always need to specify parameters and headers as well. So as we explained, the principles that RESTful APIs are based upon, and we established that integrity of data and security is actually at the forefront of those considerations, then it makes sense to authenticate. It makes sense to authenticate requests that come to an API. That's what you call a secure API. So usually what does a header look like? In this short example, we want to look at the GitHub API. So I want to believe that some of us might have heard of things like the GitHub API, the Twitter API, the Kaggle API, and so on and so forth, right? So we are using an example with the GitHub API here. So with the GitHub API, you can always access information about a certain GitHub user via okay. So basically, these APIs are ways to interact with this platform to pull data from them. So that's basically what it is, Samuel. So you can use the GitHub API to request information about a certain GitHub user. So in this case, you specify in the header an authorization parameter, and you specify a bearer token. Keep this in mind. You specify a bearer token. So now anyone that has a GitHub account could go into their settings and generate a new token for their account. I'm obviously not going to share mine here. So that's why it's in braces. So with this, you can then use it to prompt the GitHub API. So api.github.com/user, and you specify the headers as my header. So with this, you are going to get a response. You're going to get a response. That's a quick interaction with this RESTful GitHub API. So now, more on the security of these APIs. There's a term called authorization and another one called authentication. You may come across auth or OAuth. They have practically the same goal, but they're different. So authentication is a verification process. It's saying, who are you? How do you get in? Like, who are you? Are you supposed to be in here at all? How can you get in here? So in the larger scheme of things, you could log into your Facebook, right? And the only thing that you need is your username and password. But now if you want to get access to some kind of data, so for instance, if you want to get some system level information from a particular website, they're going to need access. It's like working in a company and you work on the 5th floor. Your access card can only get into the 5th floor. If you need to go to the 7th floor, then you're going to need to upgrade your level of access, which is what authorization is. Authorization is saying you could be in the building, but you can't access some certain resources. Does that make sense? So that's the difference between authentication and authorization. And again, like I said, what level of access do you have? That is why you then need access tokens. So as you can see here, in this example this first example, this was an authorization example where we needed a bearer token. And because it is particular to you and it is a matter of, okay, if you're in the building and you need access, then you should be able to make that request for access. That's why you can generate your own token from GitHub by yourself from your own profile. So once you have that, it already knows for a fact that, okay, you authenticated. I mean, you got authenticated to be able to get access to the token. So now before we authorize access to this resource that you're looking for, then you need to present to us your token, which is the case that we have here. Now, the second example is a simple case of authentication. So with the same API, you enter your GitHub username and your GitHub password. And with that, you get the same level of response. So now the GitHub API can be accessed in both manners. There's authentication or authorization because the GitHub API allows that. There are APIs that do not allow that kind of access. Another thing that you need to know is that there are different platforms that actually monetize access to their APIs. So before you can get an API, you might get a free tier authorization level, and then you pay for new API keys. There are cases like that, but generally, to at least get the freemium level of access tokens, you get it from your own settings, from your own account. A general rule of thumb is that the API keys provide an added layer of security because first and foremost, you can only get an API key if you know your account password. That's why they always say your API key is personal to you. So using an API key for verification or validation is 2 layers deep in terms of security. But now there's a risk of if you enter your username and password, then you've literally given the key to the kingdom. Because once someone can access your account with your username and password, you get a whole lot more than the API keys. So generally, if any API or if any platform has the option of using an API key to access it, I would advise that you take that option using the API key. Then, so the auth keyword is actually a parameter to the get function. So it is not for GitHub API. It is a parameter to the get function. So these methods usually take a lot of parameters to help you specify, to narrow down your requests, basically. I showed one of a get statement that I used the parameter params earlier. So it's not specific to the GitHub API. It is for the get function. Okay, so our next section is on data formats and handling. So as a quick summary, we had looked at how to access data from these different sources. Now, whatever we have got from those resources could be one or more of these data formats that we're going to be looking at. So the first one we'll be looking at is CSV. The next is JSON, and then last that we'll be looking at is HTML or XML as hypertext markup for extensible markup language. So the first one that we're looking at is CSV files. How do we handle CSV files? Now, CSV files are simply text files that come with some form of delimiter. Now, what is a delimiter? A delimiter is also known as a separator. And how does this come to play? I will give an example of what a CSV file could be named as. It's always with the extension .csv. So example file.csv could be an example of a CSV file. that you'd come across. Then, like I said, it's some text file with any form of delimiter. So either a comma, a tab, or anything else. You could always define a delimiter in a file that is generally a CSV file. So an example of what a CSV file could look like is what we have below. So notice that the first line contains what we would generally think is a header, right? So you have Z time, OECD, TSLP, WD, all of these are header columns. They're all columns contained in the data. And we can see that they are separated by what? A comma. So this file is literally, quite literally, comma separated values file. But then there could also be some files where instead of the comma here, you could have another character, or you could have a tab. A tab is generally like 4 spaces at a go. So regardless of what the separator is, you could always handle them like CSV files generally. So one thing that you might have noticed with this is, despite the fact that there is some form of rule to how the data appears, it is still not the easiest thing to read, and certainly doesn't look as friendly to manipulate. So as such, there could be some common issues that come with reading CSV files. So one thing is the values themselves could contain comma. So you said something is a comma separated value, right? Comma separated value files. So what if the time here and the comma in between? Then it means rather than read the whole term, it's going to stop at, say if you had a comma between 2017 and 08, then it's going to read 2017 as a separate value and everything that comes out as another value. So that's one major concern when dealing with CSV files. Another one is the encoding format. So depending on the version of the say the editor that created the CSV file, or some metadata information coming from the devices that this file has interacted with, or sometimes even the version of the library that you want to use to access the data. The format of the CSV file could be troubling. You could read it and display it in some funny way, or not read it at all based on the encoding. So that's another common issue. Then the almighty issue that still continues to win people till date, even so-called experts, is passing date values. So sometimes you have a CSV file, and I mean, looking at the example that we have here, the first 2 columns are meant to be dates. How do we know this? Like, it doesn't appear like a date, right? So many times you want to pass the date as an actual date value to appear like a date. So those are some common issues with reading CSV files. And based on that, I put out a simple example to show how to deal with these 3 common problems with CSV files. So the library that we're going to be using for this is the pandas library. So, I mean, any data beginner or learner would know that the 3 musketeers for a data scientist is, or they are NumPy, pandas, matplotlib. So import NumPy as NP, import pandas as PD, import matplotlib as MAT, whatever. So we're going to be using pandas for this exercise. So we are trying to read some file known as KPIT weather, right? So P is a read CSV. Now you could close the bracket after KP weather.csv. You could just close the bracket and that's it. If the file is one that is not going to trouble you, that's all you need. But we are working with the assumption that we need to make some specifications, some specificity in reading this file. So that's why first things first, we need to define our delimiter. So the delimiter is a separator that I mentioned earlier. So in this case, it's a comma. So you specify the delimiter, you wrap it in quotes so that it stands out as a character. Then quote character. So like I said, some files would come with some values themselves would have commas, some would have quotes. So you specify a quote character with you specify the character that you want to use to specify to quote characters, basically just so that it knows that a new character only starts after this quote parameter. Then you also specify the encoding of the file. So UTF-8 is like the most common encoding. So you specify an encoding for the file. So what this means is Pandas is going to use this standard to interpret the file and present it in a format that we can use. Then we want to pass dates. We want it to recognize some certain columns as a date. Then you pass this parameter dates. So this is a column name. So if there are multiple columns that are meant to be dates, you could just say date 1, date 2. Those are the names of the columns. So with this, you can read a CSV file without issues with the delimiters or encoding or passing date values. The next one is JSON data. So JSON is basically, JSON means JavaScript object notation. So we can see that its origin is in JavaScript. JavaScript defined the object JSON as a way to encapsulate multiple objects. So because your traditional data structures don't allow saving multiple data types, because the data structure is usually typed. It is rigid in the way that it works. If you have how do I call it? If you have a list and it is only a list, the best you can do is a list of lists within a list. If you have another data structure, it's probably taking some specified part. But with JSON, a JSON object could contain multiple data types. So whether it's a number, whether it's a string, whether it's a Boolean, whether it's an array, the JSON object itself appears as a dictionary in some languages. But a JSON object could also contain dictionaries as part of it. So that's one of the beauties and flexibilities of JSON. But one particularly interesting part or property of JSON is the fact that it is lightweight. So what this means is, while you have your rigid data structures, they usually come with a fixed, how do you put it? When you're defining other data structures, you define a fixed memory value that data structure is going to take. I mean, if you're studying data structures, you would see that different data structures are actually know the number of bytes that they occupy in the system for some of them. So you have a rigid structure that defines that already. If you don't have that amount of memory, you can't use that data structure. Meanwhile, with JSON, you could take all the components, you could strip the components of one data structure and put it in a JSON file, and it's still going to be lighter than you would imagine. So that's one beauty of it. It is lightweight. And another thing is it is a data interchange format, meaning that given that JavaScript was written on C as a programming language, and most of the other programming languages that we have are built upon C. What that means is if JSON is written in such a way that the structure and the objects in it are identifiable in other C languages, then it means that you could take a JSON object from, say, a program written in JavaScript and then place it in a program written in Python and it still recognizes it as a JSON object. So that's why it is regarded as a data interchange format, because if the objects in Java are similar to the objects in Python or similar to the objects in JavaScript, then a data structure or a data type that is holding all of this data could be interchangeable between those multiple languages. So that's an advantage of JSON data. And when you're looking at the JSON data, it typically appears in name value pairs. So meaning name, Jabar, school, CMU, job, data scientist. That's what you call a name value pair. So next slide, we'll look at an example of a JSON data. So this is one example of what your typical JSON data would look like. So name, John Doe, age 30, email, john@example.com, address. Now take note of this. The address is going to take another dictionary. So in that dictionary, you now have street, 1, 2, 3 name, city, video, and so forth. Then interests. You can see interest is taking another data type, which is an array. Reading, hiking, and photography. A student, false, which is a Boolean. We already saw that it took a number here. So this is an example that exhausts some of the data types that we're referring to here. Like the JSON object accepts all of these data types without issue at all. So how do we handle JSON in Python? Now, Python has a built-in library that handles JSON data and files. It's called, you can find it at this address, but if you're going to use it in a Python code, Python example, you simply use it by calling import JSON. So import JSON. Now we want to see an example of how to manipulate some data using the JSON command. So I listed 4 examples here of methods that you can use within the JSON library. So any of the methods that has an S with it is referring to already existing data that's like just data that you read. Well, when you have load or dump, without the S, it is referring to reading a JSON file. So meaning you have a file that is called something.json. If you want to read it, then it becomes JSON.load JSON file, JSON.dump JSON file, as opposed to when you already have the content that you're trying to read that has been read out from this particular request. It already exists, then you use the version with the S behind it to display. So now the next one is looking at HTML or XML data. So the web is practically filled with XML tagged information all across. And why? Why is this? The XML syntax or the XML language was actually built as a way to encode data, to structure information. So, as I was saying, XML it's a simple structure. It has one rule. When you open a tag, close the tag, so that you know that anything that falls between those tags is a nested component within that tag. So there is a defined hierarchy to write in XML. Take this example, for instance. It says tag attribute is equal to value, right? Then within that, what do you have? A subtag. You close the subtag, and it will include some content. Now, in this subtag, you could actually have another subtag inside, and it goes on and on, such that by the time you get to the last item, which is say the actual content, you can always trace its origin back to what field, to what property it's found within. That's the beauty of XML. Now, HTML was built to look similar to XML, but for one reason mostly. HTML was built to display information on the web, to display data. It didn't really take structuring data as a pain point, as a matter of emphasis. And that's why you notice that there are multiple tags. I mean, when you're learning HTML initially, they tell you, you open a tag, you close a tag. But then you might have found that while writing HTML, you could close some tags or not, and the data would still display. That is because over time, because HTML is not as strict with enforcing the closing rule of tags, it has been allowed to slip. And I mean, since we're only thinking of, we want to view the data. So even after we view the data, whether it appears in the right way or not, we're still viewing the data. So some strict rules weren't applied, and as a result, HTML is like XML, but light. How do we call it now? I don't want to say low budget XML, but you get what I mean. So it is not as tightly structured as XML. So and that's why most of the web pages that you'd encounter today are written in XML, unless you're going to get the metadata about those pages, then you'd see them in the XML tag. But that's just an example. So having said all of this, we would understand why let's say some tools have been written to parse, to read XML, and they're expecting those tight rules. Say once a tag is open, you need to close that tag, expecting the rules of XML. Now you would understand why if you apply those tools to reading HTML, they might fail, because it could just go on and on, expecting an item that is actually for one tag and include every other thing that follows because that tag was not closed. So that's a familiar problem with parsing XML or parsing HTML. But there are some libraries that are written for parsing XML, primarily like elementary, minidump. But then we're more concerned about one that could read HTML and XML equally well, and that is called Beautiful Soup. So Beautiful Soup is a Python library that is very much used in the world of web scraping, because with this you could read information that you get from a web page or a web URL or any web resource, and with the processing powers, the processing functions contained in the library, you could actually easily read the information contained without stress, whether XML or HTML. So we have an example below here. This is the link to get the what's it called? The link to get the Beautiful Soup library. You can download it from here, or you could use the pip command, depending on what you want. So how do you import it? You import it from BS4. So once you download this, BS4 is like the main package. Then you download the library from it. Then you also import requests for this example. So now we want to read information from a simple website called example.com. Example.com is actually accessible anywhere. It's one of those websites that were created by the people that run the internet for cases like this. when you want to do a simple example, basically. So the URL is example.com. Now we want to get a response. Now we're not passing any parameter, we just want to get information from example.com. So that's response is request.get from this URL. Now we define an object soup, beautiful soup object, to get the content from this response, and then we specify how we want it to pass the information using an HTML parser. Then we include how we want it to pass the information. So we know that we're getting HTML, so we just have it use the HTML parser. So now, how do we extract data from the parsed HTML? What this soup is now is, it is HTML information that is already read, understood, and interpreted. So if we want to get anything from it, we just need to call the soup and look for all the, all the present tags within the text. So soup.title.text. Then that's the title. Then the paragraphs would be soup.findAll p tags. So then we print the title, and then we say p in paragraphs, print paragraph, and then the text contained in the paragraphs. Now, this is the output. This is basically what you would find on the example.com page. So the title, according to the page, is going to be example domain. Then there are only 2 paragraphs on that page. I mean, the first paragraph is, this domain is for use in illustrative examples in documents. You may use this domain in literature without prior coordination or asking for permission. And the second paragraph says more information. And that's it. So that's a simple example of using Beautiful Soup to read information from the website. So the next part is regular expressions. Now, in this section, we'll be looking at finding and matching single strings. Sorry. Next, we'll be looking at matching multiple strings, then grouping using regular expressions, and then substituting data within using regular expressions. So yeah, to use regular expressions or to handle regular expressions in Python, you use the RE library, which is regular expressions. It is available at the link listed here. So the first thing, but I think it's best to explain the the rationale behind why we use or what's regular expression here. So a regular expression is basically any combination of characters that you can find present in any string or text. That's basically what a regular expression is. It's, as the name implies, it's regular, it's an expression, but dealing with it has gained importance and prominence from the beginning of this field and everything that we're doing. A good scenario for that explains the importance of regular expressions would be, say you want to look for something, you've been reading a text, say you've been reading a PDF file, and you're looking for the occurrences of a particular word. You have to search for it, correct? You have to search for that particular word. So a good function that you're going to use there is what? Find. Now, as I mentioned, find, some of you would have realized that there's always that find function in any ID or any tool that you use to read information, including your browser. So you can always find something. Now, what you're looking for, that's text that you write into that field that is looking for the particular thing that you're looking for. That is a regular expression. So at that point, what you're trying to do is map that particular phrase, that combination of characters. That is one use of regular expression. Now, for some people, or in the course of our work in trying to say clean the data that we have. So, for instance, we know that a noun should start with a capital letter, right? And now we have in our text, there's a particular country that is present, say Nigeria. But we know that in some occurrences, Nigeria is spelled with a capital N. In some other parts, it is spelled with a small letter N, right? Now, if we want to clean up this document to standardize it, what do? We look for cases, we look for Nigeria spelled with a small letter N and replace it with what? Nigeria spelled with a capital letter N. So that's just another scenario of using regular expressions. Now, this one, that example I explained, you could easily do it in your Microsoft Word, Google Doc, even in your programming IDE or on the web in some cases. But now, if you wanted to do it within Python, to actually clean our data that we have before we go ahead and process or do anything with that data, to clean our data, we use the RE library, which is regular expressions. And I'll show you a simple example. So now this simple example wants to look for a particular text within wants to look for a particular phrase within a given text. So the example here is, the text is, this course will introduce the basics of data science. And we want to get a match. So the match is just going to search for regular data science within the text. Now we print the match and then we say print match dot start. Now the output that we get is the first thing that we ask it to print is the match. So the match becomes a match object, right? And it tells us where that match occurs, which is starts from character 41 up until character 53. And what is the match that we got? Data science. So this is an object of the match that we got. And we want to say, at what point does the match actually begin? Where did we find the match? It starts at character point 41. In this example, you'll be thinking, how did we get to 41? This is counting each individual character, including space. Do we understand? So we have 4, 5, 6, 11, 12, 16, 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 36, 37. Okay, so I guess it's not counting the spaces. So basically, each new character, that's what it's counting. That's where it starts from. So the other functions, some other useful functions I might find within the regular expression library, the match that we have used here, find iter, like find an iteration, it matches all the text and returns an iterator over the match objects. Then find all would get you all the matches within the text, returning a list of the match text only, not the match object. So the difference here is going to be, the difference between find all and match is that while match returns an object, find all is only going to return the match text everywhere it finds it without the object. Do you understand? So again, with this one, there are many examples that you could use. This class is definitely not going to exhaust everything, but it's just to show you how we can use regular expressions when it comes to when we're in practice, basically. So now, if we want to match multiple strings, so what this means is, if you want to match, say, data science multiple times, or you want to match a particular character as it appears in text, but with some conditions, and you want to manipulate it across multiple occurrences within a certain text, there are some rules for regular expression. There are some rules, there are some special characters that have meanings within regular expressions that we can use to make the work easier. So the first condition is any character at all, except special characters, quotes, full stop, $, asterisk, the plus sign, question mark, left and right braces, backslash, square brackets, the type, or normal brackets. Any character except these ones would match itself. So for example, if you say re dot match a, character A is only going to look for character A. That's the only thing it's going to match. So in this example that we had, when we did our data science, it was only looking for data science. It was only going to match data science. So now, another thing that you could do is, if you add characters within a bracket, so say you have A, B, C, and you want to do a match, it is going to return a match if in the text you have character A, B, or C. It is going to match anything within the square bracket. So that's what, if you had this thing, it would match either A, B, or C. Now, within these square brackets, you could specify a range. So in this case, A dash Z, that's how you specify a range, is going to return all the letters of the alphabet in lowercase A to Z. Now, if you replace this with capital A to Z, it's going to return all the letters of the alphabet in uppercase. Now, if you put A, capital A to Z beside this lowercase A to Z, it's going to return all letters of the alphabet in both upper and lower cases. So now the alternate of that is, if you include a caret, we know what some caret is, right? When we're writing, normally if you miss a letter, if you miss a character within your text, you just put a caret and write that thing on top of it. So that's the character we're referring to here. If you include a caret in this brackets, in this square brackets next to the character, it is going to match everything else apart from those characters. So that's, if you have this caret before A, B, and C within a square bracket, then it's going to match all the letters in the alphabet except A, B, or C. Or it's going to match any character rather present in your text except for A, B, or C. Whenever we have this backslash, so backslash always indicates a special character coming. So whenever we have /D, backslash D, it's going to match any digit. Now a digit is a number, right? A number between 0 and 9, including both of them. So from 0 to 9, /D is going to match any of them. /W would match any alphanumeric character. So what is alphanumeric? Alphabet or number. So any alphanumeric character plus underscore. So basically it is when you have lowercase a to z, uppercase a to z, digits 0 to 9, and underscore. If you have it in a square bracket, it is equivalent to /W. It is going to match all of these items. Now, /space is going to match any white space. White space is any, whenever you type the space bar, or you type the enter character. Anything that returns space of any kind is referred to as white space, and forward slash or backslash s is going to match any of such. So actual space by itself, when you use the space bar, /t, which is like a tab, /n, new line. Now I've forgotten what these other lines are. So it's going to match a space tab, various new line characters, and so forth. That's what /s is going to be. Then now the special character dot this period is going to match anything. It's going to match any character. So if you're trying to write a regular expression and you're searching for dots, it's going to match anything except itself. Sorry, except new lines. So that's /n. Whenever you have a new line, it will not match it. However, and that's because when earlier versions of the regular expression libraries and manipulations were written, the idea was to read files line by line. So what that meant is each line is a separate entity, was considered a separate entity from the rest. It is consequently that an entire text was considered, or it was written to consider an entire text to include multiple lines. So as a result of that, if you want the special character to read, if you want dots to include the new line character, then you're going to have to include this dot all to the flag argument if you want it to match a new line. But again, these are just some examples. There are a whole lot more. So now another function with regular expressions is grouping. So now, what do we mean by group? The group function is going to return all the groups present in the text as a tuple. So for instance, if you have any text and you ask it to match certain things, right? So match all alphanumeric and space and science, right? Within the text data science, it's going to print this group. If you ask it to print the matched of groups, all the groups in the function, it's going to return the entire, it's going to return all the groups you have within the function. So basically, you ask it to return everything separated by space, that's match space, and science as a separate group. So it returns data, one group, science as another group. Now, if you want to return each item within the group, so having data and science within these brackets is what you refer to as a tuple. It's a separate data structure by itself. So now if you want to return the items at any position within this tuple, you use the group I function. So I apologize, this should have been groups, my bad. So within the group I function, so it returns the group present in the ith position of the group's tuple, but group 0 itself is going to return the entire text. So if we do the same match and we print group 0, the entire text, group position 1, data position 2, science. Okay, moving on. Then for substitution, this was the initial scenario that I explained, and quite frankly, most of the time might be your go-to tool. Most of the time in practice, at least according to my own experience, maybe the most common function that you'd use. So basically returns, what you do with the sub function is to replace a regular expression with another regular expression within text. So take this, for instance, you want to replace the original text that we had in this course will introduce the basics of data science, correct? So now if you want to substitute you want to substitute data science with another item, data science. Right? So what you just do is print RE to substitute data science. That's what you have in the original text. Replace it with data science where in the original text. So what this will give you is this course will introduce the basics of data science and so forth. It could be used in different forms. Well, thank you guys. That would be the end of today's lectures.